Everyone, my name is Uri. I don't have a lot of time, so I'm going to try to give you as much info as I can without overflowing your brains. So after we saw a live continuous deployment / delivery demo, I want to take a bit of a step back and talk about DevOps principles. Just before I start, a bit of motivation around why we came about to talk about that. Ron was mentioning a lot of tools around application deployment and infrastructure management. So one of the attempts to tackle that problem is through Cloudify, which is an open source framework that we developed at Gigaspaces, and that's how we came into the DevOps world in the first place. This talk is not about Cloudify. I just wanted to give you the background for that. If you have any questions about that, Nati and I are here throughout the day. So I'll start by trying to define things. I think Ben. Where's Ben? Can't see it. Oh, okay. So I think he did a pretty good job of defining DevOps. Obviously, there are more definitions. I'm not going to spend too much time on this, but I do want to spend time on 3 attempts to define it. So the first one is from Jesse Robbins. He's the co-founder of Ops Code, kind of the living spirit behind that. And even though he belongs to a tool vendor, you can see that a big part of DevOps is culture, and I want to kind of focus on that a bit. This is Adrian from Netflix, and there was a bit of a flame war about the term no-ops. There's even a session about that later today. But it ended up in Adrian posting a message in the DevOps Google groups and asking people to help him define that. So there's no strict definition of this. So instead, what I'm going to try to do, this is a comic relief before that. So what I'm going to try to do is actually look at DevOps from a more practical perspective and see what it really means in real-life implementations. So I guess it's mostly about, and you saw it throughout the sessions today, it's mostly about delivering software faster and more reliably. This is where kind of the whole movement started. And this is where the traditional dev and ops roles kind of fail to deliver, especially when it comes to online services and delivering changes very frequently. Obviously, changes are a force of disruption to running applications. So it's about embracing changes rather than rejecting them, which is what most ops guys used to do. And there are a lot of people to blame for that, but that's not what we're looking for today. So what I did is actually browse through a lot of the materials I've read through in the last, I guess, 12 or even more months, and try to summarize them into kind of see and learn lessons. Companies such as Etsy, which is kind of the trailblazer, everything related to DevOps and continuous delivery. Obviously, Amazon, not the web services part of things are really Amazon.com and how they do stuff. Flickr, which is kind of related to Etsy because the same guy that ran Flickr operations is now head of operations at Etsy. Netflix, obviously, which is the poster child of AWS, Ops Code, and a bunch of Facebook, obviously, and Discuss. There are more companies that are doing continuous delivery, such as GitHub, for example, but these are the ones that I focused on. I think they provide a pretty good sample to how to do things. So before I start to dive into the kind of lessons, I want to kind of divide and do sort of a taxonomy, and this is taken from Jesse Robbins, again the guy from Ops Code. By the way, if you saw in his picture here, he's a amateur firefighter. He really fights fires, so he's a pretty special guy. And he divides that into, I would say, three topics. The first one is dev and ops teams and how they interoperate, and all the processes and culture that is in between those two teams, or these two organizations. And then the two bottom boxes are about how to enable this cultural shift in terms of tooling and infrastructure. Infrastructure as code, obviously, is about what kind of things, what kind of tools you need to use, what kind of mechanisms you need to build to enable those cultural shifts and processes, like continuous delivery, for example. And application as services is about what do you need to do within your applications, again, to support this paradigm, to be able to ship, for example, 1,000 deployments per day. So let's start with culture. So the first, I guess, maybe one of the biggest things about DevOps is accountability. It's no longer throwing your code across the fence to operations to deal with and to fight the fires. And this is Werner Vogel's, Amazon CTO, and this is actually something he said back in 2006, I think. If you build it, you run it. Okay, there's no such thing as a developer building code, compiling things, doing some basic tests, and then throwing it to the QA team and then to the operations teams. It's all across the deployment process that the developer is accountable for. This is John Ospo from Etsy, the guy I mentioned before, and this is actually exact quotes from what he says. Devs own their code, so they expect 24/7 contact with it. That means that if something breaks, the dev gets a call. And it's not just that the dev gets the call; it's also about sharing the burden with ops. It's about when something breaks, let's sit together and not finger point at one another, but rather try to find a solution. And it's not just ops problems that the site is down, although they are measured for uptime. It's everyone's problem. It's a business problem. And obviously, postmortems and analysis of what happened is also something that is done between the two teams. So the separation is not at all clear as other organizations. They always work together. This guy is from Facebook. He's the release engineer for Facebook. They have a pretty unique system. In a sense, it's kind of similar to what Etsy is doing. But they also have something that they call push karma, which is kind of like, does anyone here use Stack Overflow? Okay, okay, cool. So you have points and kind of karma. So Facebook has an internal system that actually does the same thing. It scores developers based on their commit history. So if you did 2 commits that broke the system or that introduced new bugs, your karma is going to go down. And then if your karma is below something like, it's from 1 to 5, if it's below 2, you cannot commit automatically anymore. So it's kind of automating things, crowdsourcing, if you will, the ability to commit and to push changes into production. And another comic relief. So this is my guru, and he's kind of saying the same thing. All right. The next thing is definition of done. And it's kind of related to accountability. It's what is defined as done. So for at least for me, when I wrote code in the last few years, defining done was actually having everything compile, and unit tests are passing. Then I push it into a SVN or Git or whatever I'm using, and that's it. And now it's someone else's problem. And I used to do that. I used to be that guy. But this is not how things should happen in DevOps. It's not someone else's problem, it's everyone's problem. And done means nothing but the code that you shipped is released. Okay? So as long as your code is not released, you're not finished working on it. And even when it's released, you're still accountable for it. If something bad happens, you need to be able to support it and to fix things quickly when they happen. Okay, next thing is measurement. And that's again from Ospo from Etsy. If it moves, graph it. Everything you can graph, everything you want, you can measure, put it on a graph. Okay? Even if you don't have any use for this now, later you can actually take those metrics and do something useful with them. We'll see an example in a second. And if it matters, if something bad happens, if something that you want to know about happens, you need to alert on it. And Ron mentioned a few of the tools that actually have all those mechanisms built in. So it's again kind of ties the culture into the tooling. So when you measure stuff, you don't just measure infrastructure. You don't just measure CPU or memory or disk usage. You also measure application metrics, like if you have an event queue or a request queue that awaits serving, measure that. If you want to guarantee some sort of response time, measure the user experience for a certain request. and also measure business metrics. Like, for example, if you have an online e-commerce website, measure how much money you're making, measure the engagement of your users. So it's about measuring all of the metrics across all of the concerns in your business. And the second thing is, don't just measure things, correlate them. And here's a nice example. So this is Graphite. Okay, Ron mentioned this tool before. The nice thing about Graphite is that it's a really easy tool to push metrics into, and that's kind of the core of things. Make it really easy for developers and operators to push metrics into some sort of a converged system, which is what Graphite does really easily. CloudWatch, if you're using AWS, is something very similar. And what we'll see here is actually, once you start correlating the business metrics and the application metrics, is something very interesting. So these red lines actually represent code deployments, okay? And the dark blue lines are config deployments. And you can see, for example, this is a business metric. How many people registered or are registering to the website? And you can see that with this deployment, suddenly the rate of registrations went completely down. So something bad happened. Maybe this code was broken, maybe it wasn't really good as the old code, maybe some assumption that the developers made is not really correct. Same for this. Okay, this is actually sales. This is a pure business metric. How much money is being made, or how much revenue is being made by Etsy at any given moment. And this deployment actually took things really, to the wrong direction. So this kind of metrics and being able to correlate them is very, very important when you talk about DevOps, because it's not just about tooling, it's about, I would say, joint fate for all the company. It's about making things and making everyone aware of what's going on at the business level, because at the end of the day, the purpose is to make the business more successful. Paint the walls, this is also very important. You'll probably hear more about that, I guess at least in the Wix session. How many of you have dashboards in your systems? Okay, more than a few. And how many of you put those dashboards on the wall in some sort of monitor? Okay, that's good. Okay, so again, it's about not just having the information, it's about sharing it very easily so everyone sees it, everyone feels what it means to be successful at the business level. All right, next one is ship early and ship often. Again, the same guy from Facebook, this is his quote. And there are two things here. First of all, small increments. We'll talk about why that matters in a second. Never ship too big of an increment. And there's a very easy way to measure what big increment is. And this kind of revolves back into what Ben has said. Undeployed code is like a lost asset, right? It's like lost value. You put some money or investment into something, but you're not really leveraging what it can give you. So the longer you wait with code that has been written and pushed into your source code repository, the more you lose in terms of value. So why fast deployments matter? So this is also taken from Etsy. By the way, all of the graphs that I use here, the references are in the slide deck, so you can later look at the full decks and articles. So what we see here is the red lines are time to recovery from various types of issues of severity. And these are, the blue lines are lines of code when you deploy when Etsy deployed something into production. What we see here is that there's quite a nice correlation, or I would say consistent correlation between how big is the deployment, that means how big is the change, how many lines of code have been changed, to the time it took to recover from severe errors. Okay, so the more you change, the bigger the risk something will go wrong, and the bigger the risk that it will take more time to recover from. Okay, and this graph actually puts it out very nicely. This is what happens if you wait for a long time. Okay, means you have a lot of lines of code. This is kind of your progress in the code in the code repository, and this is how it should look. Okay, small amount of code and very frequent changes. Okay, which kind of reduces a lot of the risk and makes everyone's job much easier. Obviously, you have to have a lot of supporting systems to enable this kind of mechanism. And if we talk about numbers, I think the most impressive one is Amazon. every 11 seconds. This actually is correct for mid 2011. Probably it's even crazier now. So it's 11.6 seconds mean time between deployments, and that's not commits. That's deployment to production. More than 1,000 deployments an hour. Okay, so some people, I mean, if you're doing 10 deployments a day, you're also good. Okay, this is really, really, most people do one deployment per month or 2 months. This is Amazon, but just kind of to show you where things can get to when you do things correctly. This is Facebook. Again, look at the amount of developers that are actively pushing code into production every week. Again, by the hundreds. You got to have those systems to support that. We talked about push comma, for example, which is a mechanism. In Facebook, for example, it's not that everyone deploys the code independently. They actually kind of concentrate all the changes every day and deploy them together. All right, the last thing about processes is the rollout mechanism. Again, I think Ron mentioned it a bit. Just know how you're going to roll out. Even if you're pushing small changes, there's a lot of things to be done to mitigate the risk. Canary tests, which actually mean just, I don't know, pick a random instance in production, put the change on that, see how things work, and only then deploy to the rest. Red-black deployments is actually more relevant to cloud environments because we can provision infrastructure as we want. So replicate an entire replica of the existing system into a new system, put the code on it, and gradually start routing traffic onto the new deployment. And then once this is once you're certain that this is okay, you take down the old deployment. If something goes wrong, you can immediately go back to the old deployment and nothing really bad happened. Dark launches are also a way to kind of test things. Just pick random instances and see how users and push them onto specific users. Again, your systems have to support that. Like if a user comes from a certain country or a certain geography or belongs to a certain organization, you may want to introduce the new features first to those users and only then to other users. And again, it's all about risk mitigation. How much time do I have? Not sure really. Okay. Okay, so the next one is infrastructure as code. So we talked about processes. Let's talk a little bit about how to make this happen. So again, infrastructure as code is about how you do the automation. And the first thing you need to do is automate everything. This meme is taken from, I think the first one that is Jesse Robbins at Chef. The more automation you have, the easier you can do things. The more you can support the processes that I just mentioned. If you don't have automation at all, it's not going to work. There are a lot of tools. Ron covered some of them. Obviously, there are others. We built such a tool, in our case, Cloudify. And it's about picking the right tools for you and using them correctly. A lot of companies actually build their own tools, okay, the big ones. So this is a tool called Deployinator, which is employed by Etsy, and you can see here each deploy has a line, and you can actually track deployments. If something goes wrong, you can see to where it was deployed, when it was done, who did the change, what actually the change was in terms of, and you actually have a link to the Git repository. So it's very easy to track things. If something goes wrong, it's very easy to do that. This is Asgard from Netflix. How many here are familiar with the Netflix open source stack, so to speak? Okay. So Netflix have, I think, at least 20 tools to support all these processes. Most of them are homegrown. And in the last 6 months or so, they start to gradually publish them into the open. So if you're using AWS, this is a very good place to look at. If not using those tools, just understanding how they do stuff. Now, in all those things, I guess a self-service data center really helps, especially if it has an API, right? Because it's going to be much easier to automate things, especially around infrastructure, if you have this kind of mechanism. If you're dealing with monolithic servers that you can't really allocate on demand and use on demand, it's going to be very hard to automate things. The concept of immutable servers was raised in Ron's session. So this is also a big enabler. For example, in Netflix case, they don't use Chef or Puppet. They actually have something that they call the bakery, and essentially what they do is the developers define what stack they want on each image, on each Amazon image, and the bakery pushes all the code into that image, creates the image, and that's it. And there are opinions here, to here and there, but their motivation is because if there's no deployment happening online, when you launch the image, if there's as few processes happening as possible, this is safer. So there aren't any, I guess, Yum installations or Maven downloads or anything like that when they launch the image. On the other hand, it makes the image much more static, and it's kind of harder to change. I guess the bottom line to all the above is infrastructure as a product. Okay, so talking about the role of DevOps teams, and we have a session right after my session about that, is operations teams are changing the role from handling operation to actually building the infrastructure as a product that the application developers can then consume and use. Okay, and this is what enables the self-service and all the automation. And there was a big debate about how to call it. A nice article from Adrian Cockcroft of Netflix, which called it NoOps, and then John Ospel got all pissed up about it. And but at the end of the day, this is what it is. It's operations kind of shifting the role into enablers rather than people that hold the plug. So that's infrastructure and application and services. This is about what we need to do at the application level to support those kinds of deployments. So the first thing is divide and conquer, and I think you'll hear a lot about that in the Wix session. Instead of deploying one big monolithic application, use small divide your application into small services with well-defined interfaces between them, usually REST interfaces or web services. Amazon was the first to do that. There's a very interesting article about a guy that used to work at Google and now works at Amazon and talks about all these changes and how Amazon does it really well. That's why you can move forward, and Google, up until recently, didn't do it very well. So it's very interesting to get the take and understand it. This seems like a small thing, but it's a really big thing as you look at how the business evolves. Obviously, there are caveats to that. Forward and backward compatibility of all the services you need to maintain. When you define an interface, it's very hard to change later because the more the time passes, the more other services are dependent on it. And the nice thing about having multiple services that are kind of loosely coupled is the system becomes more resilient. Okay, because now it's not one big monolithic thing that every small error can kind of break it. It's disparate services, and usually when you write a code that accesses a RESTful service, what you do is you always think about what happens if the REST service is unavailable. So that makes the entire system kind of more resistant to failures. There's a whole kind of theory around that's called anti-fragility, and it was mentioned in the recent AWS event by Adrian Cockcroft. Another thing is resilience in the software stack. So it's not just about building the tools around it, it's actually building resilience into application, because we no longer assume very expensive hardware and fiber channels and reliable storage and all that stuff. In most cases, we're running on the cloud, on VMs even, which are far less reliable. And you'll hear a lot about that later in some of the sessions. So you have to build the reliability into the code. So that means a lot of things that enable you to kind of mitigate the risk of things. Feature flips is one nice concept. You'll hear about that in Wix as well. So the idea is to, whenever you deploy new code, is put a toggle on it. Some sort of if statement that says, if a certain configuration flag is turned off, this feature is no longer available. And by default, that's what happens. You actually ship the code, and only when the business decides that the code is valuable in terms of business perspective, you turn on the toggle. But the code itself is in the code base, is in production, even before you use it, which increases stability. And then again, if you see that some feature is breaking things or causing bad behavior or hurting the business, you can toggle it off quite easily. This is an example for like a dashboard of this kind of thing. Facebook calls it the gatekeeper. They do it a lot. Wix does it. You'll hear about it in the Wix session and a lot of other organizations. You need to be aware of that, of the fact that once you go that path, it means that you may end up with a lot of dead code of old features that you don't use anymore. So you need to be very careful about that, and all the time take care of removing the code paths that are no longer used. Everything is built for free. Okay, this guy's from Netflix. He's their reliability engineer. And at Netflix, yeah.
Just want to mention that about the feature flips. I used to work for YouTube, and they have an aspect is just test. Use a flag that is too old. So
oh, cool.
Has a
nice. Okay. So expiration on feature flips. Thanks. Yeah, so Ronald's saying that when he worked at YouTube, they have, on top of the feature flips, they had a mechanism that if you used a feature that is too old, it would fail a test. So you immediately know that you're using a code path that is too old or is no longer valid. So built for free. So in Netflix, everything is built for free. Every service, every piece of data is replicated at least 3 times. And yeah, that's kind of, in the Israeli army, we do everything in 3. Lucky number. Like I said, data, Amazon S3, for example, everything is replicated 3 times at least. In the Netflix case, they take a great deal of care to make sure that, for example, when they replicate data, it goes not just to 3 instances, but to 3 different availability zones. So if a whole availability zone goes down and things happened, nothing really, no data is really lost. And the last thing is what we call circuit breakers. So it's also very interesting. It relates back to the service orientation of your application and how to deal with dead services more systematically. So the idea is very simple. When you're using when you're calling a service from your code, you're doing it from using a special library called the circuit breaker. And that library actually counts, if something fails, counts the number of times that the service is not responding, or takes measurement of the amount of time that the service is not available, and then takes corrective actions. So it kind of forces the developer to mitigate the risk and to deal with things when the services are not happening, kind of have reasonable fallback behavior when services are not really responding. And if you go back to the anti-fragility thing and making the systems more stable, this is a very good example for that. And they have a whole dashboard around that. They call it the Hysterix from Hysteria. And it's also open source. It's part of the open source stack. It's a Java library, and then like a whole framework around it of how to look at things. And for example, here you can see this is the service that you're calling. This is the errors in the last 10 seconds. This is the traffic, okay, or the kind of a throughput to that service. This is the request rate, and across the cluster, really impressive, like 20,000 requests per second, and a bunch of other metrics that give you a very good visualization. If something goes wrong, this is a very good place to go and see what services are not responding. So it's very easy to kind of find the root causes that way. And again, because you're doing service orientation and dividing and conquering everything in the application, it's very easy to trace root causes. All right, last thing, fire drills and monkeys. Anyone heard about the chaos monkey? Okay. Yeah, so just today actually, yeah, so it's not just about monkeys, actually it's about gorillas and Kongs and a bunch of other mechanisms. This is also part of the Netflix open source stack. They call it the simian army. So it's a bunch of mechanisms to essentially randomly fail parts of your system. Okay, so the chaos monkey just uses, they have some sort of nice discovery service. It picks random servers from the discovery service and just takes them down periodically. And think about the effect of that on developers, on you as developers. Right? If you're a developer and you know that at any given point in time, someone wants to pull the plug on your code, you're actually going to write your code differently. This is the whole kind of deal with the monkeys. And now they have the Chaos Gorilla, which takes down regions, and they're deploying the Chaos Kong, which will take down availability zones, complete availability zones in Amazon. That's the level of resiliency that they want to reach. This is really advanced stuff, okay? Some say that it's kind of an overreaction of Netflix to some events. But nevertheless, a lot of people don't do it automatically, but do fire drills, like pull the plug in a planned fashion and see what's going on, and then kind of trace all the errors and fix their code. All right, so to summarize, I guess a lot of tips here because I don't have a lot of time, kind of rushed through that. I guess the key lesson here is there are a lot of things to do if you want to enable a true DevOps organization. And at least for us at Gigaspaces, building a product like Cloudify, we think that the main challenge now is to take all those concepts and automation tools and basically making them accessible to more people, okay, through new products, through new services. And I think this is the main challenge because most of the people that are doing continuous delivery at that level are either big organizations or organizations that are which have a lot of track record around that. There's a giant list of references here for those that are interested. We're going to post the slides online, and that's it. Thanks.